In this lesson, we're going to look at a one-way ANOVA. Here we have three groups, Group 1, Group 2, and Group 3. Each group has a set of data, and we're going to give it each one three data values. So Group 1 is a 1, 2, and a 5. And Group 2 has the data points or values 4, 2, 4, and 2. And Group 3 has the values 2, 3, and 4. Now generally we have more than 3 values in a data set, but I'm making it so that we have a small set of numbers in our data set just for simplicity's sakes. And so in our one-way ANOVA test, what we generally do is we start by making a hypothesis. And our hypothesis that we're testing is called our null hypothesis. And we write it as H sub 0 or not. And our null hypothesis here, when we do a null hypothesis, we usually are comparing things that would be equal. So we're going to hypothesize that the mean or average for group 1, which we specify with a mu1, is equal to the mean or average from the set of values in group 2, which is mu2, which is equal to the mean or average of the values from group 3. Now this is our null hypothesis. I'll put this here. We call this our null hypothesis. And from this we get our alternative hypothesis, which we generally call H sub alpha. And our alternative hypothesis would say that there's at least one difference among these means. And I've written it out, at least one difference among mu1, mu2, and mu3. And so this is our alternative hypotheses. And the next thing we need to declare is our alpha level, which is really the level of our accuracy. And generally it's 5%, so we'd say 0.05, which gives us a 95% confidence interval. And I want to point out that we used mu for our means here for our hypothesis because we are hypothesizing about the population means, and that is the population that each one of these groups came from. When we talk about the means for a sample, then instead of mu, we'll use x bar. Now our next step is that we're going to need to find our F statistics, which is our F critical value for an alpha of 5% based on the degree of freedom of these 3 samples. Here we have an F statistic. An F statistic is a value you get when you run an ANOVA test, that is an analysis of variance test, to find out if the means between 2 or more populations are significantly different. An F test will tell you if a group of variables are jointly significant. Our F statistics is a ratio of the variation among the sample means over the variation among the individuals within the same sample. Here we have a visual of a probability distribution, and we are showing our F critical value. If this is the F critical value, then this shaded region here represents our alpha value that we declare at the beginning of our test. This gives us our confidence interval. When doing an ANOVA test, you declare a null hypothesis. If you have significant results, it means that your results likely did not happen by chance. So now what we're going to do is look at our degrees of freedom. And what we use for degrees of freedom is a DF. And we'll start by finding the degrees of freedom between our values. And this is k minus 1, where k is equal to the number of values in each group, and we can see that we have 3 values in each group, which means the degrees of freedom between is 3 minus 1, which is 2. Now we need to find the degrees of freedom within. And the degrees of freedom within is equal to n minus k, where n is our total number of values, and we can see that we have 3 plus 3 plus 3, or 3 times 3, we have 9 values, so n is 9. So that gives us an n is 9 minus k, which is 3, and 9 minus 3 is 6. So our degrees of freedom between is 2, and our degrees of freedom within is 6. And the degrees of freedom total is the sum of the degrees of freedom between and the degrees of freedom within. So it's 2 plus 6, which is 8. So we're going to use our degree of freedom between, degree of freedom within, to find our F critical for an alpha of 5%. Now what we need to do is find our F statistics for our critical value, with alpha being 0.05. Now we know that let's move this over to the left, our degree of freedom between, I'll just put a B, or I'll write it out, between, is equal to 2. And that's what we have across the top here. And then we have the degree of freedom within, and that is a 6. And that's what we have across here, or down here, vertically. So what we want to do is we want to start it from 2 and come down for the degree of freedom between until we get to a 6 for degree of freedom within. So let's take a little closer look here. So we're going to, let's blow this up a little bit. So the degree of freedom between is a 2, which is a 2 right here. So let me find red. All right, so we're going to come down from 2 this way. And then our degree of freedom within is a 6, so we're going to come out this way. So from 6 we're coming out this way, and we sort of follow this over and we follow this down, we end up with this value here. So our statistic is 5.1433. So this gives us an F critical statistic for an alpha of 0.05 of 5.1433. Now we're going to calculate the mean for each group. So let's start with group 1. And this time we're going to use an X bar. So here's the mean for group 1 is going to be the sum of all the values, 1, 2, and 5, divided by the total number of values. So that's going to be 5, 6, 7, 8 divided by 3, which is 3 goes into 8 twice. So 2, with 2 left over, 2 and 2/3. So that's about equal to 2.6. Now the mean for the second group, for group 2, we sum up our values 2 and 4 and 2, divided by the total number of values, and this is also 8 over 3, which again is 2 and 2/3, which is approximately 2.6. And then we have the mean for our last group, and we'll sum up our values 2 and 3 and 4 divided by the total number of values, which is 3. And we have 4 and 3 is 7, 8, 9 divided by 3. And so our mean for group 3 is 3. And since 2/3 is actually 6 repeating, let's round these both to 2.67. Now the next thing we're going to do is find the grand mean. And to find the grand mean, we want the grand or sum of all of our values divided by the total number of values n. And the sum of all our values, well, what we can do here is we can add up, let's see, the sum of the first 3, that's 8, the second 3 was 8, and the third group of 3 is 9, so it's 8 plus 8 plus 9, and 8 times 3 is 24, plus 1 is 25, so that's 25 divided by the total number of values, n, which is 9. There are a total of 9 values, and this reduces to, or 2.78 for our grand mean. Now we're going to find the total sum of the squares, or sum of squares total. And that's going to be, we'll have a sigma for sum, and we're going to sum up the difference between each x value and the grand mean, and we're going to square that. That means for each value, starting with the first value, which is a 1, we're going to take the value and we're going to subtract the grand mean, which is 2.78. We're going to take that difference and we're going to square it, and we're going to need to do this 9 times. So our next value will be 2 minus 2.78, and square that. Now you can see why I didn't use a lot of values here. And then we're going to, let's move this down here, then we're going to take our next value, which is 5 minus 2.78, and square that. Plus, our next value is 2 minus 2.78, and we'll square that. And then our next value, you can see where I'm going with this. I would use 1, 2, 5, then 2. Now we're 4. So 4 minus 2.78, we're going to square that.
0.78, square it, plus 5 minus grand mean 2.78, square it. And we're going to do this for all of the conditions. So if I keep going, 2 minus 2.78 squared plus 4 minus 2.7.
And if we work this all out in our calculator, our total sum of squares is 13.6. So at this point, we found the mean for group 1. I'll write that here. X bar sub 1, and that's 2.67. And we found the mean, X bar for group 2, and that's also 2.67. And then the mean for group 3, which is 3. And we found the sum, the total sum of squares, which is 13.6. And now we're going to find the sum of the squares within. And to do that, we have 3 summations, one for each group. And for the first group, we're going to do the total sum of the squares. So for each x value, we're going to subtract the mean, and that is for each x value from group 1, we're going to subtract the mean from group 1 and square it. And then we're going to do a summation. We're going to add up for each x value from group 2. We're going to subtract the mean value from group 2 and square it and sum those up. And then the last summation will be for each x value in group 3, we're going to subtract the mean value from group 3 and square that and add those 3 values up. And what do we get? Well, for the first one, we're going to take 1 minus 2.67 and square it. This is group 1. The second value in group 1 is a 2, so 2 minus its mean, 2.67, and square that. And then the last value from group 3 is a 5, and subtract the mean of 2.67 and square that. And to that we're going to add our group 2, which is 2 minus the group 2 mean, 2 minus 2.67, and square that. And the second value in group 2 is a 4, so 4 minus the group 2 mean, which is 2.67, and square that. And the last value in group 2 is a 2, so 2 minus 2.67, the mean for group 2, and square that. And now we go on to group 3. The first value in group 3 is a 2, minus the mean for group 3, which is a 3, square that. The second value for group 3 is a 3, minus the mean from group 3, and square that. And the last value from group 3 is a 4, minus the mean from group 3, and square that. And this is going to give us the sum of the squares within. And when we put this into a calculator, we find that the sum of the squares within is 13.34. Now we want to find the sum of the squares between. And to do that, we take the total sum of squares and we subtract from that the sum of the squares within, which is 13.6 minus 13.34, which gives us a 0.23 for the sum of the squares between. So at this point we found the sum of the squares total. We found the sum of the squares within. And we found the sum of the squares between. And what we also have calculated is that the degree of freedom between is 2, and the degree of freedom within is 6, and the degree of freedom total is 9. Now we're going to calculate the mean squared between, which is the variance between, and that is the sum of the squares between divided by the degree of freedom between, which is the sum of the squares between is 0.23, and the degree of freedom between is 2. And so 0.23 divided by 2 is 0.115, which can be rounded to 0.12. So now we're going to find the mean square within, which is the variance within, and that is equal to the sum of the square within divided by the degrees of freedom within, and the sum of the squares within is 13.34, and that's divided by the degrees of freedom within, which is 6. And this is equal to, 6 goes into 13 twice with 1 left over, 2.22. Round that to 2.22. So now we're going to calculate our F statistics, which is the variance or mean squared or variance between divided by the mean squared or variance within, which is, well, we've calculated the mean square variance between, and it's 0.12. And we calculated the variance within, and it's 2.22. And if we calculate this out, 0.12 divided by 2.22 is 0.05 for our F statistic. Recall that our F critical is 5.1433. So our F value of 0.05 is less than our F critical of 5.1433. This is important. So we did not get into the critical region for rejecting the null hypotheses. So here we can see that our F statistic is less than our F critical, which means that we failed to reject our null hypothesis. And therefore we support the hypothesis that these three groups have an equivalent mean.